In this video, we will show you how to simulate Gibson Assembly Cloning using a single insert fragment on Mendelgen. Gibson Assembly Cloning is a homology-based cloning technique. First, we start with the backbone, as shown in green here, and the insert as shown in red. Then, using PCR, linear fragments are created that have homologous ends. As we see here, the red insert now has a piece that's overlapping with the backbone. Next, the fragments are added to a Gibson assembly master mix that will chew back the 5' ends, allowing for the fragments to overlap through complementary base pairing, as shown here. Next, in the final steps, a DNA polymerase and a DNA ligase are then used to fill the gaps and seal the nicks, leaving you with the final product. Now, to perform Gibson assembly cloning on Mendelgen, the first thing we have to do is choose the backbone. In this example, I would like to use Lenticast 9 EGFP, so I'm going to click on it. This then opens the Mendelgen editor with the backbone, and on the left shown in a circular map, and on the right shown in a sequence map. Before performing the simulation, I would like to show you what I want to accomplish. So on the backbone here, you see that we have EGFP. Now, I want to replace this EGFP with another protein from a different insert. So I already have an insert chosen. I'm going to open that window. Here we go. So I'm going to use the insert vector P turbo YFP. And what I would like to do is take the turbo YFP right here and then replace the EGFP on the backbone. Now let's go through the steps to accomplish this. So I'll switch back over to our actual backbone. Then to start the cloning simulation, I'm going to click on the cloning icon shown right here in the menu. When I click on it, it shows a drop-down of all the different cloning techniques supported in Mendelgen. I'm going to click on the Gibson Assembly Cloning. This opens a cloning tab with a panel below that shows the steps that need to be completed in order to perform the simulation. Now we see the first step is already complete. It's just choosing the backbone sequence, which is, of course, just the vector shown in the editor. In the next step, you need to identify on the backbone where you would like to insert the fragment. As I outlined earlier, I want to replace this EGFP, so I can click right here and the location will show up. Other ways you could select a region if you want to use another place. You can click on, say, the map and drag and then release. And you can do this either on the circular map or you can switch over to the sequence map. And you can say either click a feature here or drag and release to highlight a region. Switching back over to the cloning tab, and then I'm going to click on EGFP because that's what I would like to use as the insert location. Alright, now in the next step, we need to choose our insert vector. To do this, I will click on the drop-down shown here. This gives us a list of all the vectors we have within our library on Mendelgen. I would like to use the P turbo YFP vector as the insert vector, so I'm going to click on it. In the next step, you can do further configurations on your insert. If you just want to use the vector as it is, you can go ahead and click Create Insert Now. In my case, I don't want to do that. I just want to use a specific feature within the insert vector. So to do this, I'm going to click on Feature, and it will give me a list of features from the insert vector. In my case, I want to use just the turbo YFP feature, so I'll click on it. Other configurations I can do is from the insert vector, I can add base pairs that are surrounding my feature. I don't want to do this, so I'll leave it as 0. And then I can decide if I want the feature to be in the forward orientation or the reverse. I want it to be in the forward orientation in the final product, so I'll leave it as forwards. Then I'll go ahead and click on Create Insert. And this is then going to give our insert a label, and it's going to show us it here below Inserts Created. Okay, so we have finished all of the steps to prepare for the simulation, and the only thing left is to click on Clone. Okay, great. Our Gibson Assembly Cloning simulation has taken place. Let's go over here to the final product vector and just make sure everything worked out correctly. First of all, we want turbo YFP right here. Let's see what it is. Nice. Okay, so it's turbo YFP. So the actual insert fragment has been added to the backbone like we wanted. One other thing I want to point out that was added during the Gibson Assembly Cloning simulation are primers at the beginning and the end of where the insert was added. Now I'll click on the insert and switch over to the sequence map so we can get a better view. So now what these are suggestions for the primers to be used when creating the linear backbone and insert fragment that have overlapping homologous ends. Now these are the linear fragments that you create before you run through the actual cloning. So we provide this for the beginning of where the insert is and also at the end. Okay, great. That concludes our tutorial on performing Gibson Assembly Cloning in Mendelgen. Please check out our other videos for other cloning techniques.